Good day everyone, welcome to my virtual classroom. For today's video, I'm going to be discussing with you how to graph piecewise function. So for the previous lesson, we're done with evaluating piecewise function. At this point in time, I'm going to be showing how to graph piecewise function. Okay, so if, for example, we have this function of x is equal to x squared plus 1, where x is less than 0, x minus 1, where x is greater than or equal to 0. So first, what we're going to do is to determine the shapes of the graphs. If we're going to look at the, the shapes of the graph, definitely it will give you a parabola for this function, x squared plus 1, and x minus 1 will be a line. Okay, so this will be the shapes of the graph. Parabola, since the exponent is 2, so this is quadratic function. So there. And then, of course, next is to determine the boundaries of each graph. So this is the simplest way that I'm going to be discussing with you how to graph the piecewise function, because some of the students usually get confused on how to really graph a piecewise function. So determine the boundaries of each graph. So looking at this one, okay, yan. X is less than 0, x is greater than or equal to 0, definitely. So this will be the boundaries. Later, I will be removing this. Okay, so x is less than 0 and x is greater than or equal to 0. Definitely 0 will be our boundary. Okay, so graph the parabola where x is less than 0. So let's graph first this one. As you know, so in your grade 10, it was discussed how to graph a function, right? Quadratic function. So definitely this one will be your intercept. So this will be definitely your minimum of your graph. So it's there, 0, positive 1. So since this is positive 1, so we have 0, 1. So this will be your vertex. So graph the parabola where x is less than 0. So definitely, if x is less than 0, so 0 will not be included. Okay? So this will be the shape of your graph. So 0 will not be included because x is less than 0. So there. So if you're going to look at this one, this is hollow. That means 0 is not included. So we remove the other one. So since uh, less than 0, what are those less than 0? So we have negative 1, negative 2, and etc. So this will be the graph. Okay, next. What about graphing x minus 1? So graph the line where x is greater than or equal to 0. So negative 1, so definitely the the graph will pass through 0, negative 1. So here, so since this is a line, so of course, just have to create these points. So it's a line graph. So you can also, to make sure, you can also do the graphing of a linear function. So assigning values of x, but it will take you time. So since you already know how to graph, so just draw a straight line passing through 0, negative 1. So since this is x is greater than or equal to 0, that means 0 is included. Okay, 0 is included. So therefore, so greater than or equal to 0, that means negative are not included. Okay, there. So we remove those negatives. So here are the values of your x. Okay, so now it's time for us to remove our boundaries. There. So this is now the graph of this function. Okay, so if you feel that this is confusing, you can go back to this particular part of the video and review. Okay, next, let us graph this one. 3x plus 2, where x is less than negative 2, negative x, where x is greater than or equal to negative 2 but less than 1. x squared minus 2 is where x is greater than or equal to 1. So you can try to review this again. So 3x plus 2 where x is greater than negative 2, less than negative 2, sorry. Then this one, x is greater than or equal to negative 2, but less than 1. X is greater than or equal to 1 for x squared minus 2. So determine the shapes of the graph. So definitely, we have line, this is line, line, this also line, and of course, this is parabola because of the exponent 2. So this is quadratic. Okay? So this line, line, and parabola. So you know already the shape of the graph. Okay. So first, let us graph this 3x plus 2. Let's see the boundary. Okay, determine the boundaries of each graph. So since we have x is greater than or equal to 1 but less than 1, so we can determine the boundaries which are 1 and of course negative 2. Okay, these are the boundaries. So let's draw a line for negative 2. Okay, broken. So this will be the boundary. But in the real, in the real graphing, you can no longer include this boundary. This for the sake of illustration only. So this will be our boundary for negative 2 and for positive 1. Okay? So now let us graph. 3x plus 2. So since this is a line graph where x is less than negative 2. Oh, there. So since this is your intercept now, so 2, so that means it will pass through 0, positive 2. So this is the point. So draw a line. Okay, straight line. Okay, so 0, 2. And then x is less than negative 2. What are those less than negative 2? So we have negative 3. So negative 3, negative 4, and so on. So definitely those points will be here. Okay, so now let us see the graph there. Okay, so since this is less than negative 2, so negative 2 is not included, so that's why this is hollow. Okay, and next, what about this one? X is greater than or equal to negative 2, so definitely the graph will only be until negative 2, greater than or equal to negative 2, but less than 1. So less than 1. Where is that? And of course, the intercept is 0 since this is only negative x. So it will definitely pass through the vertex. There. Okay. So since x is greater than or equal to negative 2, greater than or equal to negative 2, but less than 1. Okay, so let's see the graph. Yes. So this will be now the graph. Okay, so since x is less than 1, okay, positive 1. So this is hollow because 1 now is not included. Okay, so it's in between this particular boundary. Now, what about this one? X squared minus 2. So definitely this is a parabola and with the vertex of course, the minimum is negative 2, 0. So it definitely passed here. Okay, so let's draw the graph. Okay, so it was revealed already. So here, this is 0, negative 2, but then this is x is greater than or equal to 1. So that means greater than or equal to 1. So definitely here. Okay, and that's solid because greater than or equal to 1. So let us cut there. So this is now the graph of x squared minus 2 where x is greater than or equal to 1. That means all x's are including positive 1, 2, 3, 4, and etc. Okay, so this is now the graph of this piecewise function. Then remove our boundary. So this is how it looks like. Thank you so much. So I hope you learned something today. So definitely if you learned something today, congratulations. If you think this video is somewhat um, confusing for you, you can just go back or replay the video. And please do not forget to subscribe to this channel, Second Function TV. See you guys on my next video.